We have two charges that are being attracted to each other, but they're being held apart at a certain angle theta because of an electric field that's present. And we do need a length of each of the cables here, and the length is going to be 1.0 meters. Our job is to figure the angle that these charges are held at. Now we can imagine that there is a electric field then. Let's just draw a plate here and another plate here, and assume that they're attached to some outside electrical source. So what would cause a constant electric field would be parallel metal plates. And this side must be negative, and this side must be positive, because the negative would attract this one outwards, and the positive would attract this negative outwards here. Otherwise, these two charges would then, fall towards each other since they're opposite. So the electric field then is going to be going positive and negative, so I'll just draw a small vector this way to represent our electric field. So what we do is we look at one charge right now, and we say, well, what force is acting on this in this direction here? There must be a force electric that's pulling it this direction because of this electric field here. Otherwise, it would be attracted in there. So the value of the electric field is 250,000 newtons per coulomb. Let's record that here, 250,000 newtons per coulomb. So if I want to figure out the force electric on there, I'm going to say electric field, E, is force electric per charge. So then I'll say 250,000 equals force electric over 35 microcoulombs, so it's 35 times 10 to the minus 6. And the force electric is 8.75 newtons. Because of Newton's third law, I know the electric force then that's pulling in this direction here towards that charge. Okay, if we want to call this force electric 2, this is force electric 1. Force electric 1 is because of the outside electric field. Force electric 2 is because of the 35 microcoulomb charge pulling in there. So we know these two here must be equal to each other and opposite if this is a static situation. In other words, nothing moving. So 8.75 newtons must also be the electric force between these two charges. So I'm going to say 8.75 equals 9 times 10 to the 9th multiplied by 35 times 10 to the minus 6 times 35 times 10 to the minus 6 all over the radius between them squared. So we don't know the distance center to center here. And that's what our job is right now. So my radius that I figured out then is going to be equal to 1.26 meters. So that's the distance from this center to this center. Now what I need to know is this angle here. I'll use this left triangle here to make this easier for us to envision. So I know I've got 1.0 here, and then my radius divided by 2 is then going to equal 0.63 meters. Because if the total distance is 1.26 from here to there, then it's 0.63 right here. Now let's see, my angle theta is right here, the one that I want to know. This is the opposite side, and this is my 1. So I can just say the sine of theta is equal to my opposite over hypotenuse, so 0.63 divided by 1.0. And then I can just take the inverse sine, and my theta turns out to be 39 degrees.